which is pretty awesome. Let me just pull up one thing here. So it is 4 o'clock on the dot, so I'm going to go ahead and just get started. So hey everyone, my name is Paul Reese, and I'm a developer programs engineer on Firebase over at Google. So today we're going to talk about two different tools, Flutter and Firebase, and how they can be used for rapid prototyping. So whether it's at a hackathon with only 1 weekend to build something, or you have an idea for an app that you just kind of want to test out before you really invest in it, a lot of us have been in a situation where we want to build something that gets the job done quickly. So during the normal prototype development process, developers will plan out what their app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and then build a clean and organized prototype, right? So yes and no. Some people are going to stick to this like super formal process, but when building out a quick prototype or just a proof of concept app, a lot of us, myself included, just want to open up an IDE and then start coding, and then we'll sort of figure it out as we go along. So given this, I'm going to talk about the two tools that I just mentioned earlier, Flutter and Firebase. So both of these are easy to use and address different development problems. Flutter is for the client side, and Firebase is for the backend. Both are designed to be easy to use and are well supported with content and documentation to make getting up and running as easy as possible. So while I wouldn't necessarily say this is a deep dive, this presentation is going to look at a lot of code and tools that'll hopefully be helpful in getting you up and running with Flutter and Firebase. So while it might seem like a lot up front, I can't really stress enough that you don't need to memorize everything. All of the code that I showed in this presentation is going to be available in the slides. I'll actually share a link in the workshop chat here at the end of this, as well as have everything up on my Twitter already, where it's pinned, and that'll be at the end of this as well. And it looks like this is also being recorded, so you should be able to go back through and just rewatch it and kind of rewind to the slides and whatnot that you want when it actually becomes useful. So what I hope to do with this talk is help you leave with the vocabulary looking at both of these tools further when you are ready to use them. So with that, let's go ahead and get started. First, let's talk about Flutter. It's a UI toolkit that uses the Dart programming language to build out native apps for multiple platforms on top of C++ using a 2D engine called Skia. So this is actually the same engine that's going to be used by Chrome, Android, and a few other platforms, all from a single SDK. Again, I didn't mention already, I guess, but it does use the Dart programming language. So while the tool itself is built using C++ for the efficiency aspect of it, you don't actually need to use C++ to do anything with this. It's all going to use this Dart programming language. And then since everything is actually built from a single code base, you can create your prototypes for multiple systems, like Android or iOS, without requiring specific developer knowledge about each of those platforms. Flutter is also completely open sourced. So not only is Google working on it, but so are many members of the development community. So rather than being walled off from the internal workings of the tool, you can actually dig into the code to see exactly how Flutter is doing, what it's doing, as well as send in your own pull requests if you want to improve it. So I actually just checked this morning. It looks like there's about 22,000 contributions from the global developer community. And that actually just keeps going up as more people are discovering and trying out the platform. So to give you an idea of how fast this is actually going, there were about 18,000 or so 6 months ago. So good 4,000 different contributions over the last 6 months. And that's after it slowed down a little bit just because the actual platform has been released and it's kind of matured over time. So aside from Flutter being cross-platform, probably you're wondering why you should use it for rapid prototyping, especially since there's other tools that exist that do similar things. So like most development decisions, the answer is basically, it depends. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to easily tie into device hardware using external plugins and packages that can be imported into your project. And it uses widgets, which we'll kind of dig into a bit more soon, to create a UI component, UI components programmatically, rather than requiring something like a layout file, XML thing in Android, or a storyboard from iOS. One other feature of Flutter that I also think is just super valuable is hot reloading. So you don't need to restart your entire app to test out small UI changes like colors and themes and whatnot, or even just changing text that are going to be static. So instead what will happen is UI changes will automatically be applied in your running app as you change those various values and then hit save, and it'll just kind of show up on your phone or web page or like emulator or whatnot. And then to follow up on the it depends answer, There's also going to be times when Flutter isn't the right solution for you, and it's better to figure that out early in the development process. So for starters, games are a ton of fun to develop, but Flutter just isn't really at a point where you can make most types of games quick enough to call it a rapid prototype. You'd have to write a lot of components from scratch that other platforms are currently going to give you out of the box. So in these situations, I'd actually say check into Unity, or there's some other mobile frameworks for games that would probably be more useful for you. It'll also compile down to the native level. In addition to this, calling native APIs directly just isn't super easy. So normally you would write native Swift or Kotlin code, and then use these things called platform channels to communicate back and forth to the native level through this kind of bridging process. So while this isn't necessarily a deal breaker, it is more work than just throwing some UI together and then calling it good. And then the next thing to consider is audio support, or rather, a lack thereof. So while audio isn't supported by native widgets that already exist pre-built into the system, there are third-party plugins out there that can provide this functionality. So again, everything is open source. The development community is kind of actively putting things together to solve the weak points within the platform. But that does bring me over to my next point. So while there are a ton of plugins for Flutter, some of the third-party libraries that developers have just grown to love aren't really available right now. So you'll have to weigh the necessity of things like that versus working with what Flutter does have before you actually decide to use the tool. Fortunately, though, there are alternatives to most things, but we'll kind of dig into that more later. It does just take a little bit more research. You can't just say, hey, I want the retrofit library that I'm used to from Android to work in Flutter. There's some workarounds that you have to go through. And then finally, Flutter doesn't really have support for additional form factors, like watches, televisions, and cars. So right now, Flutter does have very limited support for Wear OS, but no support for platforms like tvOS. Cool. So like we've talked about already, one of the biggest draws to Flutter for rapid prototyping is that it's an easy-to-use tool for creating custom UIs. So the first part of this presentation is where this talk is going to start getting into a little bit more of the technical side of things, as I want to give an overview of some of the ways that Flutter can be used to build out custom UIs. So when you're working with Flutter, everything is considered a widget, and all UI is described by widgets in this tree structure. So one key term that you'll see in Flutter documentation around this is aggressive composition, which essentially just means that aside from some very basic widgets, the widgets that you use in your app, either custom ones that you've put together or that come built into the platform, are going to be made up of other widgets. So you can sort of think of them like Lego bricks, where you just kind of connect them together to build whatever you want. So while there are hundreds of widgets out there, I want to go over just kind of a few of them at a high level to give you an idea of this fundamental part of Flutter. And again, the goal here is to just give you the vocabulary of what's out there so that when you want to go look into it yourself, you kind of know where to start. And then, as I'm sure a lot of you know, you can't really start with anything in the software world without Hello World. So let's go ahead and take a look at this example to get an idea of how Flutter is going to use widgets to create a bare bones user interface. So all of our apps are going to use the main function as their entry point. And in there, you can initialize various components and start your Flutter application. You can also see a center widget in the example, which will, as you can probably guess, it's going to center the content in the middle of the device screen. And then another widget that seems relatively self-explanatory is the text widget, which, yes, it's just going to show some text. One thing that is kind of useful with this, though, is that the text widget also has a few properties that can be applied to it. So the first one is just the string that will be displayed by that text widget. And the second one is this named optional property, in this case is text direction, that can be used to customize the widget. So all said and done, you're going to end up with this stunning example of a beautiful, simple user interface that pretty much does nothing, but it does give you a little bit of a foundation. So before we really get into how to use some useful common widgets, I do want to divert for a moment to just touch on how Flutter can be used on multiple platforms. We've all seen apps that use multi-platform tools where they just don't look quite right compared to the system standard UI, such as Android apps that look like they were designed specifically for iOS. So what makes Flutter handy here is that it's able to tell what platform it's on, so you can actually apply the proper UI elements for your app based on the OS. So you can actually see we have a couple examples here up on the screen. So this is the same exact app running on both iOS and Android, emulator, simulator, all that good stuff. But they each actually look native to their respective platforms because of the UI components that they're using. And you can see like some of the animations went on how you transition and all that sort of thing, just so that it kind of has that feel for users, so that it doesn't feel out of place when they're trying to use it. So this functionality is actually available through the Dart.io package that can be imported into your apps. When the user is on iOS, the platform.isIOS flag is going to be set to true. And if the user is on a different OS, then that flag is going to come through as false. You can also see that we're using a standard ternary statement here to expand the proper widget for whichever platform the user's on. It's also kind of worth mentioning that the platform.whatever, it has is Android, is iOS, and I think there's a few others now as well. So you don't need to just use this one flag. You can use whichever one's going to make most logical sense for you. And then after you've actually checked that flag, you can expand an iOS-specific Cupertino widget to have it look like a native component when on Apple devices. So for this example, we'll take a look at using an iOS-styled slider from that Cupertino package. You will need to make sure that you import the Cupertino Dart package into your app, though, in order to actually have this styled widget available. And if the user is not on an iOS device, then what you can do is you can expand a regular slider as a part of the second option in that ternary operation. And then finally, you can see that both of these sliders have properties that can be set on them. So while the base properties are the same in this kind of incomplete example, there are some differences in the components, such as a background color property that's only going to apply to the regular slider. So you'll want to check the documentation or even the source code whenever you do use a platform-specific component, just to make sure you're setting the correct attribute rather than always assuming they're going to be the same. And then since that last slide, just kind of for the sake of space, used an incomplete code sample, I actually included a complete sample for the slider here just so everyone can see it. So the value for the slider is actually a double that's saved outside of this widget. The active and inactive colors are set for the material design version of the widget, and the onChange property is set to maintain state as that slider is actually used. So one thing to actually pay attention to here is that if the onChange property is not set, then the slider is going to be unusable. So what will happen is it'll just be grayed out, and when you tap on it, nothing's actually going to react or do anything. So you need to make sure you include that onChange property within the slider widget so that you can use it. And then, like a lot of things in Flutter, this widget is relatively straightforward, but you will need to check through the source or just the documentation to understand why certain properties are needed or what they do. So like I just mentioned with onChange, that's actually all going to be listed in the documentation. So if you go through and read that real quick the first time you use this, you'll get an idea of what's going to be necessary and how to use it. And then the next component that I want to talk about is the list, since honestly, most apps are essentially just list and detail screens. So there's actually a lot that you can do with list, like setting them up for infinite scrolling, having items react to long presses, and adding various custom composite widgets that each do different things. So to keep everything simple for this example, we'll start by just looking at the code for a super basic list of generated text items with a circle icon. And then after that, we'll take a moment to look at adding a kind of a swipe to dismiss feature to your list, similar to what you can see in this demo image. So I'll just give it a second so you can actually see. So yeah, there's the sliding, and you see like the blue background with the trash can. We'll actually look at implementing something similar here in a minute. So the first widget here is the scroll bar. So while it's not necessary, it does provide, as you can all probably guess, a scroll bar on the side of the list so that users know how far along in the data they are. After that is the actual list view widget, which is going to provide the scrollable area that contains and controls the list items. So this widget also has a collection of properties that can be set to customize the list. So similar to what we saw with our text view earlier with our Hello World example. So here you can see that we're actually setting up a padding at the top and bottom of the list view, though the actual only required property is going to be this children array, which will house the items that exist inside of this list. And this next part is where the component gets just a little bit more interesting, at least. So while you can include just a simple list or array data structure of other widgets, there's also this great list.generate call that can loop a set number of times to create widgets for your list view. So in this case, we're simply going to create 100 items that'll be displayed in our app. So this is exceptionally useful when you are doing a rapid prototype, because when you want to build out your UI, you're not always going to have your data available just to kind of, and you're going to want to see like what things are going to look like as you're putting it together. So you can just kind of mock some data using this list.generate call, and you can see how things work, how they function, what they look like, before actually having to tie everything together with your backend. Cool, so each of these 100 items is actually going to be made up of a single list title widget, which is going to implement the material design specs for list items for you out of the box. And it's generally used to display some just kind of text and leading item, like an icon for each of the list items. And as you might expect, this list tile is going to have its own properties. So the first one here is the exclude semantics widget, which is going to wrap a circle avatar. So what will do is it's going to display the index for the generated list as an icon at the start of the list item. And then since it's wrapped by this exclude semantics widget, it's not going to be read by accessibility tools like screen readers, meaning that it's not going to just add a whole bunch of noise for your users that do need to use those tools. It is worth noting, though, that the exclude semantics widget should be used really sparingly and only when there's a very specific and beneficial reason to get around accessibility tools. So if somebody doesn't need to use a screen reader, taking out the extra noise for an icon that's more of a UI, like visual component, is going to make their life a lot easier. So it's just kind of nice to do that, to consider them. And the final part of the list tile widget in our list view, it's probably the most simple. It's just going to be a single string in a text widget that's going to represent the content of our list item. So this will be similar to the one that we saw in the Hello World example, except it's not going to have that text direction property. Cool. So while it wasn't very much code, it does create this kind of simple list view for our Flutter apps. So I actually have that same exact code running in this graphic, but I also modified it to include a swipe to dismiss feature like we talked about earlier, so that we can actually talk about how you could add something like that into your prototypes. So let's actually go ahead and dig into that now. So the core of this functionality is, yet again, another widget. So in this case, it's called dismissible. What's nice about this is that we don't need to replace anything in our current list to make swipe to dismiss work. The dismissible widget is just going to take the list tile widget from the last section and add it as its own child. So if we ran our app at this point, each item in the list view will be swipeable, and it'll actually be completely removed from the list view if completely swiped off the screen. And then while optional, the background property does help let users know when they are swiping away on an item by changing what's going to appear behind the list item during the action. So in this case, I'm just adding this sort of, like this container widget that's going to set a background color of a very light green color. You can also set a secondary background color if you want the user to see a different background when they're swiping from the left versus the right. So if you have like a delete direction and an archive direction, just like you would have like an email app, you'd be able to differentiate those for your users by setting different colors on the background. And then one thing that's worth noting here is that since the background property is going to accept any widget, you can do some kind of fun and interesting things in that area, like loading in an animated GIF for the list item's background. So while that doesn't necessarily mean you should, it is kind of fun when you want to try and play with some things. So obviously a GIF in the background of every list item is not going to be the most performant. But what you can do here is you can essentially create a more complex widget that you would have for the background. So like earlier when we saw the swipeable item where it had the trash can icon and the blue background, that itself would be a composite widget that would be used in this place. And it's also kind of a nice example of how with Flutter, anywhere that accepts a widget can use any widget that's out there or any custom ones that you make. So you can kind of do some really complex things just to add some really unique features to your app based off of that whole structure. Cool, so now that we've looked at what we can do with the background of a dismissible, let's go into a couple more properties. So the first one is key. This is a required property that needs a unique value to keep things in order when you're removing items from your list, as it's going to interact with the actual data structure that's driving the UI. So to keep things simple, you can usually just use Flutter's unique key class to assign a unique key to your dismissible list item. And then finally, there's the onDismissed callback. So while it's not required by the dismissible, it is useful when you want to display something to your users to let them know that they have removed an item from their list. This is also where you would notify your backend that an item was removed if it's hosted remotely. That way it doesn't just show back up for your users the next time that they open your app. And then since they're fairly often the widgets that are actually going to be used in list views, let's wrap up our general discussion of widgets by briefly talking about the card's design pattern. So like most widgets in Flutter, this snippet is relatively lean. So the size box means that each card is going to have a predefined height on the device. And that size box will wrap a child card widget, which is going to set some general properties for the card, like the shape and the basic behaviors. Next up is the child of that child, which in this case is an inkwell. So the inkwell is actually kind of an interesting widget, as it's what the card is going to use to figure out interactive touch areas. And then you can also set up a touch area color, such as the ripple effect that you would see in Android with the whole material design spec, by setting up the splash and highlight color. And then if you decide that you actually don't want those colors to show up, what you can do here is you can set these properties to color.transparent so that they don't show up. And then finally, that inkwell is going to have its own child, which is the actual content of the card that the user is going to see. So in this example, it's a custom composite widget that's called travel destination content. So despite the complexity of that widget, it's kind of abstracted away here. So you can see that you can actually add any sort of widgets that you would want into your cards. So this concept is kind of similar to what we saw with the background of the list item on the dismissible when we loaded in that animated GIF. So here, this travel destination content widget is just a custom one that we're going to throw in there. But if we wanted to have just a text widget or a GIF or any other collection of widgets or composite widgets, we could just throw them in here. So overall, this snippet is just kind of a nice example of how Flutter is going to use a hierarchy of widgets to build the UI for your users. So like we mentioned earlier, Dart and Flutter and all that good stuff, Flutter uses this kind of tree structure to build out what the UI is going to look like. So a lot of things are just going to be widget, child, 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 all the way down to create these kind of hierarchies. Cool. So far we've covered a handful of widgets, but we haven't even really broken the surface on how many are actually out there. So to learn more, I really recommend checking out the Google Developers YouTube channel to find the Widget of the Week videos, and to check out the official widget reference documentation at flutter.dev. They've actually added a new series too to this, so there's not just the widgets of the week, but they've started doing different components as well. So they'll talk about like different networking components and some other stuff that's built into Dart and Flutter, so you can see how you would actually use those in practice as well, rather than just the UI sorts of deals. Cool, so now that we've covered a handful of common widgets, let's go ahead and get into some stuff that's going to be a little bit more interesting and as well as useful when it comes to learning the platform quickly and then creating some prototypes. So the first tool that's just, it's great, I love it. For getting up and running though quickly with Flutter is the Flutter Gallery app. So this app is entirely open sourced and it's available up on GitHub, meaning you can just kind of grab whatever functionality that you like out of it to throw into your prototypes. So it goes over a collection of widgets that use both the material and Cupertino stylings, and it has a lot of other useful features that you can kind of mess around with in this playground app. And then each widget section in the gallery app is also going to include a descriptor, and it can bring up the code that was used to create that section. So each widget page also has an icon at the top that's going to let you go directly over to the official documentation for the widget that you're looking at. So say you install this on your phone, you're just kind of playing with it, and you're like, oh, hey, this is a really cool widget. I wonder how I build this. You can go to the documentation page. It'll open up in whatever browser is on your phone. And then you can share that to yourself, or you can just kind of type the URL into like your laptop if you want to read it there. Additionally, there's also a variety of tools that can show you how to do animations, media playback, or display each of the available stock colors in Flutter to just kind of help you get your app put together even faster. And then the Gallery app also includes case studies, so you can see how common features work together in sort of this big picture scenario, rather than just a bunch of one-off widgets. So that's one of the problems I have with a lot of example apps, is they're just kind of, hey, here's how you do a list, here's how you put in a picture, but they don't give you like that whole overall grand scheme of everything. So that's what the Gallery app actually includes, is how you can see functional demos of all these components working together. So here you can actually see that we have a staggered grid view, hero animations, circular animations, different types in a single list, and a few other useful items, and just the screenshots that are here. So this is great when you're trying to put together a quick prototype, as you get examples of animations and interactive components out of the box, rather than spending a bunch of your time trying to figure out how these things are going to work through like random blog posts online, Stack Overflow, or just sort of trying to piece things together from documentation, when you can have completed examples here that are going to do what you need. And then speaking of the documentation, as you probably noticed, I've actually mentioned it a lot already. So I'm a huge fan of what the Flutter team has already put together, especially since a lot of it isn't just that standard, this component does something sort of stuff. One of the things that they have is the Flutter cookbook, which is a documentation page containing various code samples, or recipes, which is where the name comes from, for common tasks that you might want to do in Flutter. So this is just a sample of what's actually there, but you can see there's a lot of great content here that you'll use in pretty much any app, such as animations, design elements, and networking. And then the next thing I want to talk about, plugins. It's essentially just kind of a fancy word for libraries or modules, but it is one of my favorite things about Flutter. So because the development community is so active and passionate about the platform, they've already created thousands of open source plugins that you can use in your apps to easily accomplish tasks without having to go out and reinvent the wheel. So you may remember earlier I mentioned that Flutter doesn't have native audio support, but that there are plugins out there that do actually support audio for you. So you just have to import those, and then you kind of have all that functionality that you are lacking from the main platform. It's all exactly going to be this whole plugin idea. So we'll kind of dig into how you would find those. So a lot of these are going to be available through pub.dev, which is a site that was created by Google for searching through plugins and finding their documentation and their source code. So with that, let's actually take a look at a few useful plugins and how you would implement them. So while there's a ton of great third-party plugins out there, I figured I would actually start with Google Maps, since it's one of my favorites and kind of the go-to when I want to display location information for my users. So in this section, we'll go over the code that I used to make this exact demo image. So you can see here what's going to happen is it gives you a full map view. You can zoom in. It actually has some markers and drawings on the screens and all that good stuff. And it looks like you can actually see the Waterloo office for Google and stuff on there in the corner. So Google Maps functionality is actually going to be all wrapped by this Google Map widget that can be displayed on the screen. So this widget has the bulk of its functionality handled by the onMap created future method. So if you're not familiar with futures from other languages, essentially what they are is just kind of the way that Flutter is going to handle asynchronous operations by figuring out what to do in your app before an asynchronous action, during that action, and after that action has finished. So if you're familiar with Android development, you can kind of think of these like async tasks, but way less terrible. So features are going to come up a few times during this talk, though a really detailed look into this feature is a little bit outside of the scope of this presentation. So again, it's just the way to handle asynchronous operations before, during, and after the whole life cycle of them. So what's going to happen is this method is going to be triggered once the maps data has finished loading. The example for this presentation is going to load the location of Google's offices around the world as a list of objects that will then be displayed as markers on the screen. Once those office locations are loaded, the map data structure of markers is going to get cleared, and then we'll just loop through each of those offices. Each office is then going to be converted into a Google Maps marker that's going to designate the office's location, name, and address. We can actually also add an action to OnTap, such as bringing up a navigation screen or just displaying additional information about a specific marker location. And then finally, what we'll do is we'll take each marker and add it to the global map data structure that we had cleared earlier. And then once all that's done, we can go back into the Google Map widget. And from here, we can set the initial camera position and the zoom level. So in this case, I didn't do anything too complex. What I did is I just centered it into the middle of the Atlantic Ocean at 0, 0 for the lat long. And I set the zoom level to 2, which is just this kind of very high level view of the Earth. And then finally, the last thing we need to do is just add this set of markers to be displayed onto the Google Map. So once we have this data and assign it to this property, it'll just automatically, like in the background, be added onto the map for each of those markers. And then next up is Flutter. So Flutter is actually this third-party plugin, so it's not related to Google at all. But I just thought it was just kind of too cool to not include in this talk. So this plugin is great when you want to animate icons, buttons, or other items in your app to add some extra kick to your UI, which is always going to be kind of great when you're trying to sell an idea to somebody or just show it off for hackathon judges. So it's worth noting that you can do some of this manually using native widgets like Animation Builder or Transform, but it's just not really as easy. So using their animation website, which is rive.app, you can actually stage out animations that will then get converted into a vector animation file that can be imported, or rather exported from this website, and then run into your app. So overall, it took me roughly like 20 minutes of a tutorial up on YouTube to learn how to make this kind of fading and spinning star animation, and then how to properly set up the keyframes. But luckily, once you actually know how to put together one of these animations, it's really easy to make others that can help your app really stand out. And then once you actually have your vector animation file exporting, using it as simple as initializing the custom flare actor widget in your app and then assigning it to the animation file when you want it to run. You'll also notice that I'm listing the animation title as Go in one of the properties, which this is actually just what I call the animation in the web app before I exported it. So this Go text is going to be relative to whatever you name things before you export it. Cool. So while I've talked a lot about rapid prototyping for apps, it's becoming more and more common that people need to make prototypes that are going to consist of an app with a hardware device. So for this next section, I just kind of want to briefly touch on Flutter, which is a third-party plugin that helps you communicate with Bluetooth devices using the Flutter app. I'm not going to go into a ton of detail here, but this is an area that's worth knowing for people that need to make an IoT prototype. So I just want to make sure that it's at least introduced. So the first thing every Bluetooth app needs to do is scan for advertising devices. So you can do this by calling start scan on a Flutter Blue instance. You can also, and probably should, set up a timeout duration so that the scanning is going to stop after a set period of time. Next, you will listen for results to be returned from that scan, and then you can act on those results, like saving a particular device based off of its name or its RSSI value. For those of you that aren't familiar, RSSI values are essentially the received signal strength of a device. So there's a lot of math and whatnot that can go in here, but essentially what you would do is, like, you can use that RSSI value to roughly estimate how far away a Bluetooth device is from your phone. But that's kind of outside the scope of all this. But if anyone's interested, you can message me and I can go into this for days. Cool. So after saving your device, you will probably want to connect to it using the connect method. And then you can discover the services that are being broadcast by that Bluetooth device. And then depending on your setup, you may also want to loop through each of those services to do something with them in your app. So one thing you might want to do is pull each characteristic, or essentially just a piece of information, from that broadcasted service. So not only can you read those characteristics, but you can also asynchronously write back to your hardware device by using those characteristics. And then the final thing that I want to cover with Flutter is that you can attach a listener to characteristics that will be notified basically anytime new data is pushed to a characteristic by another device. So this will allow your apps to stay reactive while dealing with the real world. And then to wrap up our introduction to Flutter, I do want to just take a moment to talk about one of the more common tasks that you're going to run into when you're building out a new app, which in this case is just retrieving data from the internet and then parsing a JSON payload into Dart data objects. So this sample will go over a simple list app that's going to pull data from the Etsy API to display inventory amounts for each of the listings that's in a single shop. Though the same idea can be carried over to pretty much countless other common scenarios. So we're going to look at how we make this exact app on the screen. So the first thing you'll want to do is use a feature builder in your app, which you may remember features are a specific component in Flutter that let you decide which widgets to show during, before, during, or after loading in whatever the asynchronous stuff is. So in this case, it's going to be loading in data. So what we're going to do here is I'm going to use a new method called feature listings. This method is asynchronous and it's going to return that feature object with a type of listings, which is a custom object that's going to represent the array of items coming from the API. This method will also use the HTTP package to get the data from our API endpoint. And if that endpoint returns a 200 success code, then we'll use the JSON.decode method to convert the response into a JSON object, which will then convert into a listings object. This is done with a custom object that I created earlier called listings, using some Dart magic under the hood. It's going to convert a JSON map into a list of objects with a type of dynamic, which are essentially just kind of, you can think of them like undefined generics. And then once we have that data from that future, we can do another conversion to switch the list of dynamic objects into another custom object, which in this case is listing without the S, which is basically just an individual item from that earlier listings array. And this is going to use similar JSON conversions. So this example also sorts out the list using a simple A to B comparator operator. So that sorting operation is not necessary, but it just seems like something that people may want to use if you're putting together something really quickly and you want it to look nice. So sorting is one of those things that's always going to show up on Stack Overflow, like how do I sort the list in whatever language? So here it is. Cool, so after all of that, you can create a new list view of list tiles, just like we did earlier in this presentation when we were talking about list views and whatnot. And then for the last part of the sample, if there isn't any data in the future builder, such as during the time the data is loading, then what we can do is display a circular progress indicator until the results are available. It's actually also good practice here to handle error cases in the future builder, though for this example I didn't, just to save a little bit of space and time. So that was actually the first part of this presentation. I'm going to just check the comments here because I haven't had them up on the screen just to make sure people aren't like, oh, this doesn't make any sense. Let's see. Oh, there's a lot of comments. Cool. Let's see. Well, you know what? Then I'm going to just save this for the end just to go through because there's a lot of stuff here. Cool. Well, then for the next part of this talk, we will learn a bit about Firebase and how it's used with Flutter through Google's open source plugin, which is called Flutter Fire. One weird thing here you're going to notice anytime you look for plugins with Flutter, pretty much all of them start with Flutter. So just be aware of that when you're looking for things. That's just kind of a practice that the community's picked up. I have no idea why, but it's cool. Roll with it. But yeah, you can actually find this Flutter Fire library up on GitHub. So first, I just need to go over kind of the official pitch for Firebase. So Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during a product's lifecycle and makes them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when you're storing data. Okay, cool. So let's actually get into the practical stuff here. So Firebase is actually divided into these like 3 main categories of tools, and they each have specific goals. So the first one is to help you build better apps by making complex coding processes easier. And then there's improving app quality by helping you catch issues early and fixing them quickly. And then finally, there's this whole group for helping you grow your app by understanding how other people are using it and then engaging with them in these like meaningful ways. So as you can see here, there's like 20 different products within Firebase, and that's a lot. So while that may seem like a ton, today we're just gonna look at a subset of all of the Firebase features that are gonna be most relevant to rapid prototyping. So when you decide to settle in and start working and whatnot for Hack the North, those will be the ones that are gonna be like the most useful for you. So again, the goal here is not to overwhelm you, but rather to let you know what's available when you do need it. So before you can start diving in and using Firebase in your apps, you will need to create a new project. So you can do this over at console.firebase.com and basically just type in a project name, hit next a few times, and it'll get you set up and into your project's dashboard, which is going to look like this screen. This is just some random app that I have. I've been learning Mandarin Chinese for the last year, so I have a little app that I've been using for practice. So after that, the next step is going to be linking your apps back to Firebase. So for this talk, I'm only going to touch on the Android and iOS processes. There's also a web process, but we can kind of dig into that later, or there's other documentation. So for Android, you will need to enter in the app's package name, which you can find over in the Android manifest.xml file in your project, and potentially the SHA-1 certificate for your signing key. After that, you'll need to add some code to your build.gradle files for both the core Firebase functionality and the specific Firebase products that you want to use. You will also be provided with a Google Services JSON file through this whole like setup process that you'll need to copy into your Flutter app. It'll kind of walk you through that, or we actually have a documentation page up as well. It'll go into like the full detail of that process. And then for the iOS side, that process is similar, but I think it's actually a little bit easier. You'll basically put in your bundle ID and then copy over a generated plist file to your app, and then just install the pod files for the products that you want to use. And then after that's done, you should be golden for using Firebase on both iOS and Android with your Flutter apps. So the first feature I want to go over is authentication. It's not the most flashy feature, but there's always going to be that one hackathon judge that's going to ask you about security. So you might as well just toss it in since it's easy enough to use and it's such a fundamental part of any modern app. Just make sure that your data is going to be secure, your users log in, everything's related to them, all that good stuff. So Firebase authentication will allow your users to log into your app using a username and password, a phone number, a third-party identity provider like Google or Facebook, or a few other options. So for simplicity, I'm just going to go over a few of the more commonly used authentication features so you can kind of see how these individual ones work, how they're common, where they're a little bit different, and just kind of get you started. If you want more complicated things, we have documentation on all that as well, but I'll dig into that a little bit more later as we go along. So let's go ahead and get started by discussing user authentication just using an email and a password. So a major part of the setup process is going to occur in the console. So aside from adding your app to Firebase and including your Google Services JSON file or your plist file, you will need to enable each type of Firebase authentication that you'll want to use from the Firebase Auth section in the Firebase console. It's kind of a tongue twister to say Firebase that many times. So after project setup and enabling Auth, you can get back into the code for your app. So using email and password sign-in is actually super easy. So the first thing you'll do is just register your user's email and password, which you can do by calling this create user with email and password method on a Firebase instance. This will actually also automatically log your users in. This is going to be a common theme that you're going to see throughout using Auth and whatnot with Firebase as well, is that these method names are just really self-explanatory. So this one, create user with email and password, is going to create a user with an email and password. So kind of nice that you can just sort of look into what you want and it'll just probably be named that. And then if you want to sign a returning user in, you can use the sign in with email and password method. Also pretty easily, you're just going to basically call that method with an await, which is kind of like what you would see in like JavaScript and whatnot for asynchronous operations, and it'll return this Firebase user. Cool, so that was kind of it for that. So the next thing to talk about is email link authentication. So this authentication feature is going to take an email address from the user, and then it's actually going to send them a link that can be used to sign in. So this basically just proves that they have access to the email address that they use to register. So just like the email and password method, you will need to enable email link sign-in from the Firebase console. So this is actually just an additional option under the email and password method. So you just need to go in and activate the appropriate slider and then click that blue save button and you're good to go. You will also need to enable dynamic links in the Firebase console. So these are actually what is going to be used to generate the links that the user is going to click on. And then a few slides ago, I mentioned that you may need to enable like a SHA-1 certificate. It was kind of just like a throw out line there. But it is required for dynamic links, which means it's required for email link sign-in with Firebase Auth. These are going to be universally unique between your package name and your signing key on Android. So just be careful with that. You can't duplicate it across the board and whatnot. So it's really like important if you are doing debug and release versions of your app that you use different signing keys just to make sure everything works properly. Cool, so when you're ready to sign your users in, you will need to email them a link using the send sign in with email link method. Again, a straightforward name. But you're also going to include the information for both iOS and app packages, as well as the dynamic link for your Firebase project. Looking at this, I just realized this code is a little bit outdated. We recently put out a new change where all of this is actually going to get put into a map object that then gets sent into this method. Same exact information, same keys and whatnot, just a little bit cleaner, but you can find all that on the documentation page. It's really straightforward, so I wouldn't worry about it too much. If everything does go as expected, they should receive an email, like the one in the screenshot, that's going to contain a sign-in link for your project. So when they click on that link, it should just open up your app on the user's device. And what will happen is your app will immediately call the did change app lifecycle state Flutter method when it opens. In here, you can check to see if the lifecycle state has been resumed, and then you can see if there's a dynamic link associated with the opened app. And then if there is, you can just go ahead and handle that use case. So generally the way you would do this is by calling Firebase Auth's sign in with email and link method to retrieve a Firebase user based off of that link that was passed in. And then finally, you can just update your app state data. And then the final type of auth that I was going to go over is Google sign-in. So from my own experience, this is actually the easiest of the third-party authentication methods to use, but that's mainly because there's also a Google sign-in plugin that kind of speeds up this process. So if you're interested in the details of using other third-party identity providers, I actually recently put out a blog post up on Medium that goes into a lot more detail on these options. So you can either find that by going to the Firebase plugin or publication on Medium, or I'll have my email at the end. You can just message me, email me, whatever, and I can send that to you. So the first thing you need to do is instantiate the Google sign-in object and call the sign-in method on it. If the user's device is able to use Google sign-in, then they'll be prompted with this like sign-on dialog similar to this. One thing to note is that this is on an Android device. If your user's on an iOS device and they don't have access to this little prompt, what'll happen is it's just going to open up a web browser to give them the Google sign-in screen. Then they can enter in their email, password, whatever, and it'll just kind of follow the same flow from there. And then if the user has selected their account, you're going to receive a Google sign-in account object. So you can use this to call authentication against Google's identity provider service. And then once the user is authenticated, you can retrieve their auth credentials from the Google Auth provider that's a part of Firebase. Actually, that's not a part of Firebase, that's part of the Google sign-in plugin. And then finally, you can actually retrieve the Firebase user using the Google authenticated credentials. So this is where you're going to use the sign-in with credential, and you're just going to pass in the credential that you'd created earlier from that Google Auth provider. Cool. All right, so next I just want to talk about the two database options that are available in Firebase. So the first one, real-time database, is essentially just like a simple JSON tree structure that's available to store and access data. So this data is stored and synced between users and devices, and its main goal is just to provide a backend data storage solution without having to go through the whole like terrible process of setting up your own database server, authentication schema, REST endpoint, and everything else that goes along with building a typical data infrastructure. I probably shouldn't call it a terrible process. There's a lot of people who love that. I'm not one of them. So before we dig into that code, though, it is worth mentioning that you will need to provision your Firebase database from the Firebase console. Once that's done, the next thing you will need to do to use the real-time database in your Flutter app is just create this Firebase database object. You can then create a reference to the specific node in your JSON tree structure. So in this case, the node is just going to be called messages, and it's a child of that root node. You can create as many of these references as you like as well. So in this part of the code, I'm just creating a reference to a counter node and then reading the value from it one time before printing it. And that's completely unrelated to accessing the messages node that we're doing for the rest of this. And then after you have your reference, you can associate it with a listener in order to take action on any of the data changes as they happen. And then finally, I just wanted to introduce this like new graphical widget from the Flutter Fire library called Firebase Animated List. So this works like a standard list, but it'll animate as items are added or removed from it. And it works specifically with Firebase references to listen for data changes without you having to like tie everything together manually. So if this widget doesn't work for your use case, there's also the Firebase list and the Firebase sorted list widgets as well. And then just for reference, this is actually the same screenshot from the first real-time database slide with that animated list. So now you can actually see what it looks like with context. So you can see how things will just kind of accordion in and out and whatnot as data is added. And then the second option for your database setup is called Firestore, which is a database tool that allows you to group data using a document collection structure for straightforward access. So it's going to offer many of the same advantages as the real-time database, such as real-time syncing, offline support, and scalability. but it also supports basic queries in addition to direct data access. One thing that's actually really important to remember here too is that Cloud Firestore can be used in conjunction with the real-time database, as each actually serves its own unique purpose within your app. So one of the questions we get a lot is, like, can I only use one or the other? And no, you can actually use both at the same time, in the same app, all that good stuff. It just depends on what you're trying to build. Again, the answer to pretty much anything you'll ever get asked in computer science or programming is, like, the answer is, it depends. This is one of those situations. So, like most things in Firebase, it only takes a few lines of code to do the most common actions, like reading and writing data. So by first getting an instance of the Firestore object, you can retrieve a child collection from Firestore. Once you have that collection reference, you only need one call to add a new document item to it, or another call to retrieve all of the documents from the collection just one time. So despite those two operations being pretty simple, there's also, let's actually look at a little bit more complex example. So in this case, it's going to be listening for changes in your data. So you can do this by creating a stream builder object that's going to listen to a specific path in Firestore and update whenever new items come down. I'm not going to get too deep into what a stream builder is, but you can kind of think of it similarly to features in Flutter, except that they're going to be activated anytime new data is sent to them. So it's essentially just kind of like a listener pattern. So this object can then check to see if a data snapshot is available. And if it isn't, it can return a default UI widget. So in this case, that's where that text loading widget is coming in. So otherwise, what you can do is you can retrieve the data from that snapshot. And then using that data, you can update your app state and UI. So in this case, we're just going to use the length of the data snapshot to define how large a list view should be. And then we can display list tiles in that list using the actual documents that have come down. Again, list view, list tile, very similar stuff to what we've seen across the board on multiple sections with Flutter. It's one of the most common patterns you're going to see with mobile apps. So while we've talked about database options already, sometimes you need to store and serve user-generated content, such as images or audio files, directly in your mobile app. So you can use this using cloud storage for Firebase. So uploads and downloads are handled by the Cloud Storage SDK, and they're resumable, making them more resilient to changes in network connectivity. So when a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which honestly can be critical when you're trying to deal with the kind of network conditions that people often have with mobile devices. Similarly, users will be able to download their content from cloud storage. So once the user's content is uploaded, it can be shared with other users of your app using the same exact SDK. And since you're likely going to run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rule system along with Firebase authentication to restrict content according to your app's requirements. Actually, I think this is the first time I've mentioned security rules. They actually work with Firestore, real-time database, and cloud storage. I think a couple other products, but those are the main ones. And that's basically just how you would set up the logic around your security so that you know that people aren't accessing what they shouldn't be, or that only certain people are uploading whatever to your actual structure of your backend. That's a whole other topic though. Cool, so when you want to upload a data object to cloud storage, you can get a reference to the storage path and then create a storage upload task by calling put file or put data on your storage reference with the item that you want to upload, as well as any metadata that you want associated with that item. You can also save a reference to that task in order to pause, resume, or cancel the action. And then downloading a file is similarly easy. We'll kind of go over a simple case here where you can specify a storage reference for the file that you want and then get its download URL. And once you have that, you can actually pull down that file using an HTTP request, like we discussed earlier when going over the Etsy list item app. There's also other plugins out there that'll handle connection issues and retrying, but we're going to just stick to kind of the bare bones implementation here for now, just so you get an idea of this, and save the rest of that stuff for other times. And then once a response is received, you can actually retrieve the information about that file and then use it in your app. This is a huge code block, real simple stuff. It's just pulling down the information from that HTTP response and then essentially displaying it. And again, the code will be up later. Cool. So Cloud Functions for Firebase are these single-purpose functions that are executed in a secure, managed environment for your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or just interacting with other Google or external services. So these are great for just kind of handling backend logic for your app without having to set up a whole complicated backend, which is kind of the general theme of the build products within Firebase. So just to provide a quick example, I have this function written using Node that's actually hosted up via Firebase functions. So when it receives an HTTP request, it'll just get the date and respond with the hello message, as well as a current timestamp. And then what you can do is you can call that function directly using Flutterfire's HTTPS callable object with an optional data map. And then you can just listen for the results asynchronously to update your app's UI. And then at the last FireConf, Firebase Summit, we also released a new product called Extensions. Actually, I guess it's not the last one. The one, not this most recent summer in 2020, but the one before. But basically what these are, they're just essentially pre-made functions that handle common tasks for developers without having to reinvent the wheel. So you can find them in the console to see exactly like what'll work for your app and just kind of install them, and they'll be there to handle logical operations for you. And there's still being more being released over time. So that's actually one of the things I do on the side at work is I've been developing even more of these to release. And while it's the only product that I'll talk about today that isn't in the Firebase build grouping, app distribution is great for rapid prototyping when you need to work with other people on a project. So you can upload your install file and add either an individual or a group into the console so that those people can receive an email and download your app without having to go through like an app marketplace or even physically like plugging into your computer, especially right now because nobody's physically plugging in anybody's computers because none of us are seeing anybody. So it is what it is, but it's kind of great for dealing with that problem. And then after those users have installed your app, they can give you feedback or work with your app in order to speed up the development process. Cool, we got 3 minutes left and I got a couple slides, but we're doing good. So the final thing that I want to talk about is Firebase ML, which allows mobile developers to enhance their app's user experience by applying machine learning. So Firebase ML provides a variety of models that can run quickly from the cloud with this like high level of accuracy and detail. So the out-of-the-box models currently allow developers to recognize text, apply labels to objects, and identify landmarks. Developers can also take their own custom TensorFlow models and run them through Firebase's APIs. So you can upload your model up on the cloud and then just basically pass the same information over, but you'll be able to run your own custom models. And then Firebase's ML is just a little bit more complex than the other Firebase products, but it's still not too bad. So for this example, the image and image rotation parameters are found prior to running this method, and how you retrieve an image will vary depending on the needs of your app. So you can actually find a great example, like retrieving an image using scanner utils and all in the camera stream up in the Flutterfire GitHub repo. But essentially it'll be like this code, but more complex. But once you have all the necessary data, you can just call the process image method on your Firebase ML object to get everything started. The 3 methods here that actually aren't defined in this snippet are concatenate planes, build metadata, and rotation into image rotation. So each of these are just helpful methods. They're up on GitHub, but in short, they just kind of manipulate or add image data so that it can be analyzed properly by Firebase ML. Cool, so we've covered a lot today. If you want to learn more about Flutter or Firebase in depth more than what has gone on here, then the top few links are going to give you a ton of information and resources like code labs and videos. So for Flutter, I highly recommend that you check out the Flutter cookbook that we talked about earlier. You can also find more information about all the features available in Flutterfire up on GitHub. The YouTube channels are also amazing. All of our Firebase Summit talks recently are up there, plus a whole bunch of other snippets. And then Flutter has a ton of things that are just great for like, hey, I want to use this one thing. How do I do it? And it like goes through the whole process. So again, my name is Paul Reese. I'll actually post the slides for this talk up on the little chat feature here in Hopin, or you can go to my Twitter account at TK14863. I have everything pinned at the top there as well, and plus cat pictures and stuff that no one cares about, but I like them, so it just is what it is. You can also reach out to me directly through my work email at ptreese@google.com if you have any other fairly in-depth questions. We are at time, but if anyone wants to stick around, I can answer questions and go through all that good stuff. And let's see, yeah. Let's see, there's a ton of stuff. You guys are super active. Let's see. Streams can be saved. Should we already have Flutter downloaded? No. This is just kind of an overview. What language does Flutter use? A whole bunch of people answered that. Great, thank you all. Widgets are pretty much just UI only. Looks like other people answered that as well. And then everything in Flutter is a widget. Does Flutter come with a device emulator? Yes and no. It's actually going to use the Android or iOS ones that are already available. So you would actually set up those development environments. And then you can actually run like Dart and Flutter and all that like framework stuff in Android Studio, Xcode, and VS Code. So it'll just kind of use the frameworks that are already there and then it's built on top of it. Let's see. Can childs have childs? Yes. Let's see. Why is there no close bracket on exclude semantics? I have no idea. Maybe I typoed the slide. I would have to check. So we define functions within each widget. What is that supposed to do? Yes, you can take functions and associate them with widgets if the widget itself accepts them. It's a lot like React components. Yes. Very similar in a lot of that stuff. Async tasks are the bane of my existence. Yes, I did Android development for like 7 years. No. Let's see, futures are a lot like JS promises. Some stuff about where we are. There's a lot to go through here. Let me just kind of zoom down to the bottom. Anyone can email me if you have other questions too. Is Flutter and Firebase mainly used for mobile apps? Yes and no. Firebase is pretty agnostic about what's there. There's like a Python SDK, web SDKs, all that good stuff. Flutter mainly works for mobile, but they have been slowly adding in web support. It's not great. It's still experimental, but it is there. I've actually done something relatively recently where we have a product called Firebase Hosting, which lets you put web pages and whatnot not up online, where I actually created a Flutter app, compiled it down into like a web version, and then hosted it up that way. Using Firebase for our hack qualifies for the Google Cloud Prize, correct? I believe so. If this is like most of the other Major League hacking events, then yes. Would you use Dart to create cross-platform apps? If you are using the Flutter framework, yes. If you're using something like React or any of the other ones, then no. Dart is just kind of the underlying language that's going to be used with that Flutter framework. How do I use or get a JSON array when I use request.send? I would have to review. Essentially, there's like some magic under the hood for parsing that Flutter will do with that. Let's see. It's a standard Saturn V model, not Lego either. Actually, it is the Lego one. I just have it broken in sections and I 3D printed like little holders for it so it'll fit on the wall. I've got the moon lander up there as well and the International Space Station. But that's kind of off the tangent here. And then there's like a knockoff Chinese like Millennium Falcon because I was not going to drop $800 on one. It's like Lepin's Star Renars. So how do we connect the back and front ends of the app? So the back end would be your Firebase stuff, and then the front end stuff would just be all this Flutter. So you would actually use the Flutter Fire library and plugin to actually connect all of that through. And I think that's pretty much where we were. If anyone has any other questions, though, my email is here. Just gonna go with that. Cool. All right. If anyone has questions, there's my Twitter, there's my email. I'm actually going to be up on Discord as well this weekend and all of that. So if anyone has questions, feel free to ping me. I'll be there. All right. See y'all later.